Hi, in this lesson we're going to talk about domain and range. Now recall, a function is a collection of ordered pairs, and the domain of the function is the set of the first elements from those ordered pairs, and the range is the collection of second elements. So in this first example, the domain is going to be the set 1, 3, 5, 7, and the range is 2, 4, 6, 8. The second example, the domain is going to be 1, 3, 8, and 11. And the range, let's see, we've got 4, 4, 4, and 2. But if something shows up twice, you only count it once because this is a set. We don't put repeated elements in there. So I'd put in 2 and 4. Okay, so this is from a domain and range of a sparse function that just has a handful of points in it. If we want to look at it, the domain and range from a graph, graphs consist of sets of points, each of which is an xy ordered pair. The domain is the set of all the first elements, like before, so that's all the x elements, the x coordinates, and y is the set of all, or the range is the set of all y coordinates. So let's look at these two examples here. This first one, let me make it a little bigger. The domain here is all real numbers. Because this graph, it goes from one side to the other and it keeps going forever. Maybe that's not totally obvious there, but so the domain is all reals. And we could write that as all real numbers. We could also write it using this special scripted R. Or if you wanted to write it as an interval, you could say everything from negative infinity to infinity. Now the range on this one is a little more interesting. The range in this case, if you look at the y values here, the y values, the highest they ever get are 1, and the lowest they ever get are -1. So the range is everything from -1 to 1, and we include both of those endpoints because it actually touches 1 and -1. All right, let's look at this over here. The second function is a parabola, and it keeps going on forever in both directions. So its domain is going to be all reals. Its range, if you look at all the different y values that it takes on, well, it goes down forever. So it takes on everything, down there. But the biggest y value it ever takes on is up here at the vertex. Now let's see, what is that? 1, 2, 3, 4. So the range is going to be everything from negative infinity up to and including 4. I'm going to draw in a third example. The square root graph. It looks like this. Let's see. Let me slide that over so you can see it better. I'll put it up here. For this one, the domain is, if you look at the x's, they start at 0 and it goes up to infinity because our x's go from here over to there. Now the y values, we get everything from 0 up to, it goes up forever. So our range here is also going to be 0 to infinity. Let me slide those in so they're visible. All right. Now let's look at a couple more. Suppose we're given something like this where it says use graphs to determine the domain and range. This first one here, we could probably even do it without, actually we can do both of these without the graph, but I want to graph them to see it. This first one, if you think about it, it's a parabola. And it's not just, it's a parabola, and the fact that x squared has a positive coefficient means that it opens upward. So its domain is going to be all reals. Its range is going to be whatever the y value of that vertex is from there up to infinity. So let's graph it and look at it. If I put in y equals x squared minus 4x plus 3, we can see here's our parabola. And the vertex there is 2, negative 1. So the range here is everything from negative 1 to infinity. And the domain is going to be all reals. All right, let's look at this next one. This is a cubic function, so let's graph it. You might already know the answer, but let's look at it. X cubed minus 3x squared plus x plus 1. All right, if you look at this, notice it goes over here, it goes up as far as we want. So it's looking at its range first. Its range goes up to positive infinity and then down to negative infinity. Or I could have said all reals. And its domain is actually the same, because we can go everywhere from all the way over to the left to all the way over to the right. Let's see. So using a graph, we can look at that and get those domains and ranges. All right, I want to do a couple more sort of strange looking graphs. Let's look at these guys. These graphs, this one, let's look at it first. I'll do this in blue. Its domain, if we look at all the points on this graph, it contains everything from here down to there. It doesn't actually contain this point up top, though. So if we look at the x-coordinates of all of these points, this one, this open circle, has an x-coordinate of negative 1. And the closed circle has an x-coordinate of 1, 2, 3, 4. Now, the closed coordinate, or the closed circle, we actually include that. So we include 4, but we don't include the 1. Reason being, this function, it's defined, or rather it's, as we go up here, it contains all these points up until this last one. The open circle means that that point's not contained. So its domain is everything from negative 1 to 4, but not including negative 1. Now its range, similarly, is going to be all the y values of all the points on this line, but not including this open circle endpoint. So let's see, the lowest value in the range is 1, and the highest value is 4. 4 being the y coordinate of this point, and again, that's not included. All right, let's look at the other one. On this one, it looks kind of like a half parabola or something like that. Again, if we look at all the x values that it takes on, it doesn't quite get an x value of negative 1, but it gets everything up to it. So we get everything along here, and then this is supposed to keep going out to infinity. So the domain here is everything from 1 to infinity, but not including the 1. All right, if we look at the range, this is supposed to stop up here at 4. So up here it hits 4. So if we go around here, we get everything from 4 down to negative infinity. Now, we want to put that in order, though. So we'd say negative infinity to 4. Do we include the 4? Well, is this point actually on the graph? Yeah, it is. So we'll include the 4 for the range there. So notice the open circle on this one. It had an effect on the domain, but it didn't affect the range. The reason being, this point right here that's not included, it looks like it's the point 1, 2. Well, the y value 2, though, is included again over here. I shouldn't say again, it's included over here. So we don't have to worry about missing a y value because of that. All right,